Welcome to another video from Know It Deep. Did you ever wonder how a C program is converted into an executable when you use the compiler? And how the computer understands the executable and run it? This video is going to explain you this. The process of converting a C program to executable file is called compilation. The software which translates a source file written in high-level language to an executable is called compiler. A C compiler takes input file as C file and gives executable file as output. A C compiler has four stages involved: a preprocessor stage, a translator stage, an assembler stage, and a linker stage. The first stage of C compilation is preprocessor stage. The input file for preprocessor is .c file and the output file is preprocessed file, which is indicated using the file extension .i. The preprocessor processes all the preprocessor directives in C file. A preprocessor directive is any line which starts with hash. Mostly used preprocessor directives are macros, file inclusion, and conditional compilation. Macros are defined using hash defined. File inclusion is done using hash include, and conditional compilation is done using hashif or hashifdef. There are some other preprocessor directives as well, which will not be included in this video. Now we can try to understand preprocessor stage in deep using a small program. Now we will open an editor and start writing the program. I will create a new file and save it. I will save it as test program.c. We can try to write a small program which can be either built into an executable that can add two numbers or built into an executable that can subtract one number from other. The first preprocessor directive which we will be using is hash include. Hash include is a preprocessor directive which will direct preprocessor stage to include a header file. For example, hash include stdio.h will include standard input-output header file into the C program. So any function or variable which is declared in this header file can be used in our program. Next preprocessor directive which we will use is hash define. Hash define is a preprocessor directive which can be used for declaring macros. Let's use hash define to declare two numbers. Hash define number 1 as 100 and hash define number 2 as 50. Now we can define one more macro named build for sum for conditional compilation. Let's write the main function. Int main, then printf sum equal to %d number 1 plus number 2 and printf difference equal to %d number 1 minus number 2. Now we can use preprocessor directive for conditional compilation to either include line number 9 or include line number 11 in preprocessor stage. For that we can use hash if def build for sum. So as build for sum is defined, the line number 10 will be included in preprocessor stage, and hash else if the hash define build for sum is not defined, then the line number 12 will be included after preprocessor stage. So now after the preprocessor stage, line number 10 will be inside main and line number 12 will not be included. Now let's direct the compiler to stop compilation process after preprocessor stage and see how the file looks like. For that, save the program, open the folder where the program is saved, and open command prompt. Give the command gcc -e testprogram.c -o test program.i. This command will stop compilation process after preprocessor stage and save the file into test underscore program underscore program.i. The compilation is complete and we can close command prompt. Now there is a file named test underscore program.i. Now let us open and see the file. Here we can see that standard input output header file is included in this file. Now we can go back to testprogram.c. See here, the line number 10 was inside a hash if def. So the build for sum is defined. So the line number 10 will be added as part of our .i file and this line number 12 will not be added. So we can verify that. Here we can see that the printf sum line is included in the .i file and the other line is excluded. A developer generally use comments in their program for the reader to understand the code easily. Removing the comments also is done by preprocessor. We can try to understand that part. Here, this is the main function. We can add a small comment here saying that main function starts here. Here we can add a small comment number 1, then another comment here number 2, and we can add one more comment for saying the meaning of this particular hash define. Define this for building a program to add the numbers. We can save the program and now we can try to see how preprocessor process this file and outputs .i file. Let's open folder where we saved the program. Open command prompt. Then give the command gcc -e testprogram.c -o test program underscore 1.i and give enter. The preprocessor stage is completed. We can close command prompt. Now we can see that another file .i is generated. Let's open this file and see the main function. Now we can see that the comments which we added are removed. The next stage of compilation process is translator stage. The translator converts a program written in C language into an assembly language program. An assembly language has different instruction sets for different architectures. Now, let's learn how to stop a compiler after translator stage. For that, open the folder where we have saved the program, open command prompt, and give the command gcc-s, then test program .c, or either we can give test program .i, because the test program .i is the output of preprocessor stage, which is the input for translator stage. So for this translator stage, we can give input file as .c file or .i file. So if we are giving a .c file, it will be preprocessed, then feed into translator stage. If it is a .i file, it will be directly given to translator stage. So we can give this command gcc-s testprogram.i. The translation is complete. We can close the command prompt. Now we can see that there is a file named testprogram.s. This is the output of translator stage. We can open the file and see the content. We can see that the same program which is written in C language is converted into assembly language. The next stage of compilation process is assembler stage. Assembler stage converts a assembly language program into machine understandable language, which is binary. Now let's learn how to stop compiler after assembler stage. For that, open command prompt and give the command gcc-c and then either the .c file or .s file. We can give testprogram.s. It's complete. Let's close the command prompt and we can see that there is a .o file. This is the object file or the binary file. We can open this file and see the content. We can see that the file is unreadable for us. For opening the .o file and seeing the content, we have a command. For that, open command prompt and give the command objdump objdump -d and the .o file. Now we can see that this is the .o file, that means binary file. Here there are 4 columns. The first column is the offset address where the program is going to sit in RAM. Second column is the binary executable. Third and fourth column is the assembly language code. The last stage of compilation process is linker stage. The linker links multiple .o files into one executable file. Also, if we have used library function, linker will link our code with the library function code. Now we can open command prompt and make the executable. For making executable, we can give gcc command, gcc, then testprogram.c -o testprogram and give enter. The compilation is complete. We can close the command prompt. We can see that there is a file named testprogram.exe. We can try to open that file as well. The .exe file is also unreadable using Notepad. We can use the same command objdump to see the content of .exe file. Let's open cmd. Give objdump -d testprogram.exe. We can see that the binary executable is getting printed. This is the final executable file which is formed after compiling a C program. This is end of this video. Thanks for watching.